Well, welcome everybody, and I hope you will enjoy today's session. Today we're going to talk about powering next generation digital twins. As mentioned, I'm Nelson Petracek, CTO of TIBCO Software, and we're going to take this opportunity to walk through what a digital twin is, a little bit around architectures that do support the implementation and deployment of digital twins, and then also how technologies like blockchain can facilitate the creation and the productization, if you will, of digital twin solutions. So with that, let's get started. So the first thing, just one quick note about TIBCO for people that may not be familiar with who TIBCO is as an organization. TIBCO is a software company, been around for a number of years, 25 plus years, based in California. And TIBCO really focuses on three core aspects. We focus around connecting to any data from any location at any speed. We talk a lot around how we can unify data through concepts such as data management, data quality, and master data management and all the complexities associated with that. And then we also talk about how we can use data to make better predictions and to help us really drive digital transformation. So TIBCO has software capabilities in each one of these areas, but as you can see and as you've heard, it really is around data and how people can better utilize data to provide competitive and differentiation within their industry. So what is a digital twin? Typically, people will hear or talk about digital twins in the context of IoT. But a digital twin is actually much more than just a digital representation of an IoT device. A digital twin can actually be a digital representation of any real-world entity or system. So you see the definition here from Gartner, and this is one of many definitions. But I like to look at digital twins as really a digital representation of a person, of a process, or even of a complete organization, right? It still is it's much broader than just an IoT device, which is normally how you will hear about a digital twin. The idea that you can use digital models to represent people, organizations, or processes is really something that I'm starting to have a lot of conversations with customers and also with partners around how this capability can be brought into an organization to further provide differentiation. So digital twin is really this broader idea of a dynamic software model. It represents some real world entity, and it really is intended to help us understand operations and behavior. Now, we can also look at digital twins from two different sides. There's the digital twins that are used for the purposes of simulation, and there's the digital twin that is used for the purposes of a parallel or real-time deployment. So with simulations, digital twins can be used to test theories. I can build an offline model based on historical data and use that digital twin to test what would happen if I tweaked certain attributes or properties of that model. The parallel deployment is more when I take a digital twin and run it alongside a real-world entity. So as a business process is executing, the digital twin is running alongside that process in parallel. As a person is doing something, that digital representation is also working and acting just like that person would. Right? So there's this idea of using digital twins for simulation, but also for parallel deployments. And we're going to talk about both of those in today's session. So what are the key requirements and capabilities that are typically part of a digital twin solution? And I tend to break this down into 5 different buckets. So there's obviously other aspects of this. There's different capabilities and different ways in which you're going to look at a digital twin if you're looking at it for the purposes of simulation or if you're looking at it for the purposes of parallel deployment and so on. But I tend to find that people do have to look at these 5 categories when looking at how they're going to build and implement a digital twin solution. The first step in many cases is to identify just what your digital twin should be. So for example, if you are building a digital twin of a person, you need to understand what the characteristics of that person are. What's their profile data? What do you have from a historical context about that person? What kind of guidelines, models, rules, things like that do you want to actually use to interact with that real world digital twin? Another way to look at this is if you're building a digital twin of a process, you of course need to understand the way that the process is currently behaving today. And this is typically not how it's documented, but how it's actually working. And so you can actually take techniques such as process mining and use process mining to collect application logs from a number of different sources and then correlate those logs together in such a way that you can identify the real world process as it is happening today. And you can also identify associated resources, what people are doing, what part of the process, which pieces are automated, where are there bottlenecks, and are there any dependencies. So the first step is really to understand what the digital twin is that you want to represent and how it's behaving today. The next part of this is that once you've identified what that digital twin should be based on, and you've identified all the different data sources that can feed into that digital twin, then you need to look at how you're actually going to source that data. How are you going to collect the data? Where's that data coming from? Is it coming from the edge? Is it coming from the cloud? Is it coming from on-premise systems? And in many cases, it's likely coming from all of the above. Is the information batch, right? Is it based on historical data? Is it based on real-time data? And then what is the technical and business metadata that's associated with those different data sources? So at this point, I'm really just trying to get a handle on all the information that I'm going to use to drive my digital twin, whether it's for simulation purposes or a parallel deployment. At that point now, I'm looking to be able to get a better understanding of how I'm going to process and execute my digital twin. Where am I going to run these models? How are those models going to be deployed? Again, if I'm executing these models in batch for simulation purposes, that is going to be a very different execution environment than a parallel digital twin that represents a person or that represents an IoT device. So in this case, I'm trying to understand how I'm going to process these digital twins, where they're going to execute, how I'm going to store any data that's related to contextual digital twins, and what my overall compute capability needs to be and where it's going to sit. Of course, the digital twin itself, in many cases, is powered by models. And these models can be something simple like rules, or they could be quite complex AI/ML derived models. So I'm going to use the historical information as well as the context and information about digital twins that I've just described to actually define what that model or models are. And that will then dictate how the digital twin is going to behave. And of course, that'll also dictate the types of decisions that I can use to drive that digital twin. And finally, of course, as all of this gets deployed and as it's running and as I've got this simulation occurring or as I'm actually running a parallel digital twin, I need to make sure that what is happening is monitored. So I need to collect that information and I need to be able to visualize what's happening with that digital twin. And that visualization might need to occur in a batch or historical context, but also in a real-time context. And oftentimes those need to be viewed side by side. So I need to build almost an analytical application, if you will, that really is supporting the execution and the monitoring and the management of these digital twins. Now, of course, this cycle doesn't stop there. This is a continuous cycle. So this information that I'm collecting from these digital twins, I'm also going to use it to then drive improvements. And so this really ends up being a circle, if you will. It's a cycle. These steps are then repeated in different ways and different priorities in order to continually evolve and improve the performance of that digital twin entity. So that's just a little bit around some of the areas that you need to consider when you're going to be building a digital twin. Now let's look a little bit around the architecture, right? What are the architectural layers that support the execution of a digital twin, again, for the purposes of simulation or real-time deployments? And there's many different ways you can draw these architecture diagrams, of course, and if I had a whiteboard, we could dive down into a little more detail. But at the core, these tend to be the way that I think about the different architectural layers. So I'm going to drill down on these here in subsequent slides, but the idea is you're creating this core foundation that is managing the digital twin. It understands how to deal with the data that's associated with the digital twin, again, either in a batch or real-time context. It understands how to store things like the state of a digital twin. And then it understands how to take the information that's relevant and share that potentially across a network of participants. And as you can imagine, that's where we start to get into utilizing blockchain technology to augment the deployment of a digital twin solution. So I will drill down on that here in subsequent slides, but just wanted to start off with the overall picture. There are different architectural layers and different patterns that are utilized to facilitate the deployment of a digital twin solution. So the first part, if I start from the bottom and work my way up, the first part is obviously how I'm going to hook into all the applications and data sources that I previously identified. And these data sources, in many cases, you want to make sure that they're event-enabled or are capable of delivering real-time data streams to the digital twin execution environment. In a lot of cases, my digital twin needs up-to-date real-time information so that it's most accurate. It won't do me any good if I deploy a parallel digital twin, something that's running in real time along with the real world entity. It won't do me any good if that digital twin gets old data. And so as a person is doing something, a passenger, a customer, a patient, or whoever that individual is, as they're interacting with their immediate world, point of sale device, a wearable for health purposes, and so on, that information has to be also up to date in the digital twin. One thing to take note of here is that in many cases, data that does not happen is more important than data that does. So the behavior that I am driving with my digital twin actually might be based on the fact that data did not arrive. And that might be more important than data that did, especially in a certain context, or especially either at a point in time or over time. So that's step number one, is to deal with the applications and the data sources. As I mentioned or alluded to already, you need to make sure that those data sources are event-enabled when it makes sense. So I need to switch from batch or polling-based mechanisms to real-time event-driven mechanisms. So as soon as something changes in that underlying data source, I get notified about it right away. Right? That's a key aspect of event-enabling or powering, especially digital twins that are deployed in a real-time context. The Event Hub is kind of the core. Don't think of it as a central engine, because of course this engine is often distributed. It's often on multiple machines. It's often deployed as technically as a set of containers or functions, or whatever that is. It's not a single engine, but logically you can think of it as a hub. Information is flowing into this hub, models are being executed, and decisions against those digital twins are being driven out of this hub. So this hub has to be the core. It has to understand events. It has to understand how to correlate those events. It has to understand whether the digital twin decision is being made in a stateful or stateless context. It has to understand if that digital twin decision is at a point in time or over time. And so these engines tend to be more declarative in nature, right? It's more of a sense and respond or event-driven style of execution interaction, as opposed to something that's more procedural or flow-oriented. It would be very, very hard to define all the possible permutations and combinations of procedural logic to power a digital twin, because digital twins in many ways are unpredictable. What a person is doing can kind of be predicted in some cases, depending on context and state and so on, but it's not as determinate as that, right? People can randomly do different things. And so the digital twin has to be able to accommodate for what seemingly would be a more random behavior. So that's the Event Hub. It really powers the core of the digital twin. Now, to support the Event Hub, you need data. And that data needs to be accessible at the speed at which is required by the digital twin execution models. So it has to be highly performant. It has to run alongside the Event Hub and really provide the Event Hub with contextual data. Now, this contextual data might be built out by feeding or updating it with real-time data, state changes, IoT device reads, or whatever that happens to be, but it can also be, of course, infused with historical data. And oftentimes that's where you start, with the data that is powering these digital twins. And then finally we get to the top of the stack. Now, everything that I've described up until now, you can pick and choose the pieces that are relevant to you in order to best power that digital twin. Same concept applies here. You don't always need this notion of a decentralized or shared or secure data network, because you don't always have a multiple participant or multi-party digital twin network. But in certain cases you do. It's not constrained just to a single entity, a single process, or even a single organization. Right? These twins can span multiple parties. I can have a business process that has multiple participants, including regulatory bodies. So in scenarios where I do need to have this very open and shared yet secure data network, if you will, where business logic needs to be decentralized, it needs to be spread across multiple parties, it needs to be transparent, and again, it does need to be secure and so on, then maybe we look at alternative technologies for providing that capability as a layer on top of the digital twin. Now remember, this layer may not contain all digital twin data either. If you're dealing with a supply chain, maybe it's only snapshots of data. If I'm dealing with tokenized assets, maybe it's only when a certain exchange of value occurs. And all the underlying details can be backed up by underlying oracles, right? Underlying state stores, things like that. Components that are feeding information into this broader blockchain-based network, if you will. So there's a lot of characteristics of blockchain that can facilitate the deployment of a digital twin, and you see some of the ones listed here on this particular slide. But of course, there are also a number of challenges. So all the information that's powering the digital twin, of course, is coming from typically some form of an enterprise application, whether it's an edge application, whether it's a legacy system, whether it's something that's running in the cloud. All that information is being generated from a variety of different sources. And so one of the questions that always comes in is, how do I get that data to my blockchain, or that decentralized distribution layer, if you will? And conversely, if somebody else injects information into that digital twin data layer, right, that decentralized data layer, what business logic do I need to execute, and how do I bring that back into my organization? And then how do I trust that? Right? So there's definitely considerations around that. Coordination and collaboration across these multiple parties can be quite challenging. There might be legal implications, regulatory implications. You have to look at how the network itself is going to be governed. How do you govern changes to the network, changes to things like business logic, smart contracts, things like that. So there is a set of complex subjects that needs to be addressed when dealing with that type of distribution. And then also you need to look at the infrastructure needs. When you're dealing with blockchain or blockchain related technologies, how do I and who is going to run these different nodes? There are no standards, so how do I deal with those aspects? How do I make sure that as blockchain technology rapidly evolves, that I'm not locked in, or at least trying to avoid that as much as possible? And then finally, I do need to ask, do I need a blockchain-backed capability? Or is something like a centralized database, such as Amazon's QLDB, is a centralized database sufficient that still provides a level of cryptographically secured information, right? Append-only data structures that are cryptographically secured so no one can actually tamper or not easily tamper with the data. Maybe that's all I need. And I don't need actually a decentralized blockchain-based framework. So these are all different considerations that one needs to look at when layering on this type of technology into a digital twin environment. Now, these use cases, of course, can span any vertical. I've alluded to a few already by talking about people as customers, as passengers, as patients. Just to give you an example, from a TIBCO standpoint, we've built digital twins to really run alongside of Formula One race cars. So you can imagine you only have a certain amount of time on track when it comes to things like testing or practice. So developing an accurate digital twin that represents that track, that car, those weather conditions, and so on, can of course be the difference between winning and losing a race. And so developing a digital twin that can really simulate real world track conditions, setup combinations, and so on, can be a very, very key aspect of how, in this case, the Mercedes Formula One team can drive towards victory. But this notion can span to, as I mentioned, any other vertical. If I take transportation and logistics as an example, yes, we have the supply chain aspect of this, where I could have a digital twin that runs in parallel and can be used to track packages, shipments, sensitive or environmentally sensitive products and things like that. But transportation itself, trains, cars, even those aspects could actually have associated digital twins. And that may be for the purposes of just monitoring, or it could be for the purposes of optimizing the way in which these twins are being utilized, again, as part of an overall organization or as part of an overall set of business processes that could be single party or multi-party. So lots of use cases in transportation logistics. This use case here, this what I call persons of interest example, is really around tracking people that you are interested in, let's say, for certain reasons, maybe good or bad. And so there's conversation around what they call the POL model, persons, objects, locations, and events. Well, if you combine those in different ways, you're really creating a digital twin of a entity, a person, and you're using that digital twin to potentially predict certain types of interactions or behaviors. And one interesting aspect of this is that in this case, a digital twin could really be powered by a graph. So you want to treat the digital twin as a series of attributes and properties that also have relationships. And so the digital twin itself can be quite complex. And so as I'm running this digital twin in parallel and correlating events against the graph, I can use the graph and graph analytical techniques to try and predict certain associations, or if associations change, as an example, what does that actually mean in terms of how I'm going to respond to the digital twin itself? Right, so digital twins are not just linear. They're not just an entity that operates in a standalone fashion. They can actually be part of a broader network. And in many cases, really representing that network as a graph can be quite beneficial. And then future considerations. We've talked about around the core components of what you look at when you're deriving a digital twin. We've talked about the different architectural layers, including blockchain that can be used to augment the deployment of a digital twin. Going forward, of course, IoT has a big part of powering digital twin, whether again it's for collecting data for the simulation or historical purposes, or feeding real-time parallel twins. Knowledge graphs, which really are extension of the graph concept that I just talked about, but I can use knowledge graphs now to power these digital twins. Or there's even further research in the areas of things like BDI agents or belief, desire, intent agents, which is almost based around the notion of autonomous software agents collaborating together in order to derive or execute on a goal or a set of goals. And so, of course, that entity, that digital twin, could comprise or be part of this series of autonomous software agents that are, again, working together, sharing events, sharing data to operate within a certain set of constraints and drive towards a certain set of goals. So this space is definitely growing and evolving, and it may not be always called digital twin, but it's really a very useful way to represent real-world entities, simulate changes to those entities, break things as you want to break them, and do so in a way that's much more agile and less costly than it would be if you tried to do all those things against the real-world entities themselves. From a TIBCO Labs standpoint, TIBCO Labs is an arm of TIBCO that actually works on a lot of these innovative technologies and associated capabilities. It's all open source. It's very much targeted at building out a community around collaboration and working on solving some of the hard business problems that exist out there in the world today. So there's a number of projects that we invite you to check out, contribute to, play around with, that really support the development of these digital twin capabilities. One of these projects is Project Discover, which is focused around the building of smart contracts and then taking these smart contracts and deploying them within a blockchain network. So I can actually take a model in Dovetail, and then which is built using a set of visual tooling. I can take that model, I can actually generate either client APIs or smart contract artifacts based upon that model, and then deploy those, of course, anywhere I want to deploy those, whether that's in the cloud, whether that's in a on-premise or containerized private cloud context, or whether it's different blockchain environments such as Hyperledger Fabric, R3 Corda, and so on. And so Dovetail is really a mechanism or a tool that can really facilitate the development of business logic, deploying that into your blockchain framework of choice, and then exposing that as a set of APIs that can be used to integrate with external systems. Some other projects, Project AIR is really focused around IoT, how I can collect IoT data, process IoT data, and also use edge analytics to really handle the IoT data, again, from an edge context. So think things like computer vision and so on. And Project Discover is focused on process mining. So if I do want to better understand what my business processes are and how they're actually executing, Project Discover can help you with that overall process. Finally, we also have a graph database. So talking about knowledge graphs, with treating relationships as first-class citizens and using that as a core foundational component for defining a digital twin. Of course, you can use graph databases to do that as well. For all this information, feel free to check out the various links that you see here on this particular slide. There's a number of locations you can go to find out more information. Be sure to also check out our meetup page where we're going to be posting more sessions and other webinars and things like that we'll be hosting. That includes things like hackathons. We have an open source Community Day that we also sponsor every year, and more details can be found on the meetup pages about when that's going to be held. That's always a good conversation around different open source projects and their applicability to real world business problems. So, and then finally, there is a white paper that's associated with this particular webinar. So feel free to download that white paper, use it as a guide to get more details around the topics we discussed today, and have some fun. Start playing around with where digital twin can help you and your organization and see what kind of solutions you can help develop. So with that, I hope everybody had a really good session. Hopefully that was informative. If there's any questions, as was mentioned, please let us know.